Let's solve a calculus problem involving finding points where the tangent line is perpendicular to the x-axis. Our curve is given by x squared plus 4x plus y squared equals 0. Let's break this down step by step. Step 1. We need to find dy dx. To do this, we'll use implicit differentiation, since our equation isn't solved for y. Let's differentiate each term with respect to x. The derivative of x squared is 2x. The derivative of 4x is 4. And when we differentiate y squared, we get 2y times dy dx. Step 2. We want the tangent to be perpendicular to the x-axis. This means that dy dx must be undefined, or in other words, dx dy must equal 0. Step 3. Let's solve our equation for dy dx. First, we'll isolate the term with dy dx. Then we'll solve for dy dx. Step 4. For dy dx to be undefined, the denominator must equal 0. This means y equals 0. Step 5. Now we can substitute y equals 0 back into our original equation. This gives us x squared plus 4x equals 0. Step 6. Let's solve this quadratic equation. We can factor out an x to get x times x plus 4 equals 0. Therefore, x equals 0 or x equals negative 4. Therefore, the points where the tangent is perpendicular to the x-axis are 0, 0, and -4, 0. Let's visualize these points on the curve. And there we have it. We've found and visualized the points where the tangent line is perpendicular to the x-axis. Thank you for watching.